Hey, all, today we are going to begin our talk about probability, and we are going to start with some general probability rules. Some of these you might already know and be comfortable with, but it is a good idea to go over them uh, and freshen them in your mind. And of course, it's okay if they're not something you remember, and that's why we're talking about it. So the first rule of probability is that any probability is a value between 0 and 1. Inclusive means that we can have a probability of 0 and we can have a probability of 1. So probabilities are either reported as fractions or decimals. When you see something written as a percentage, that's a percent chance. This might be semantics, but a probability is a fraction or a decimal from 0 to 1. Of course, a probability of 1 means that the probability that that thing will happen is certain. It's definitely going to happen. A probability of 0 means something is impossible. It won't happen. There's no way it will happen. If we have different outcomes that can occur, the probabilities of each of those individual outcomes must always add up to 1. And then we have here some probability notation. So this means the probability of event A. So P with A in parentheses means the probability of event A. And then when we have this is the probability of the complement of A. So similar to geometry, when we had complementary angles, we called them complements. They added together to be 90. Here, when we have probabilities, the probability of an event happening and the probability of its complement happening, they add up to 1. The complement is the opposite of the event. So here we have a scenario where we're driving and we pass a light and we find that the light is green 35% of the time. I apologize if this is a little grainy. If it is, you can look at the PDF on Canvas to see it more clearly. But basically what we're saying here is that the light at this intersection we drive through is green 35% of the time. So the probability that it's green on any given day or at any given time is 0.35. So if we wanted to find the complement of that, meaning the probability it's not green, so we'll say green complement, we could just take 1 and subtract 0.35 from it to get 0.65. So if the probability of the light being green is 0.35, then the probability of the light not being green is 0.65. Another probability rule has to do with disjoint or mutually exclusive events. So if we were to draw a Venn diagram of two disjoint or mutually exclusive, we can use either of those phrasings. The Venn diagram of two events that are disjoint or mutually exclusive looks like that. That means they cannot happen at the same time. There's no overlap in that Venn diagram. We call this the addition rule. This is read as the probability of event A or event B. If we have two things that are mutually exclusive and we want to know the probability of one or the other one happening, we can take the probabilities of each of those things and simply add them together. We'll go more in depth on the addition rule and talk about what happens when events are not mutually exclusive, and we want to do this. So we find out that the probability that the light is yellow is 0.4. And so we want to find out what is the probability of the light being red. You might be able to find that out quite simply, but let's do it using our rule. So we're going to find out the probability that the light is green or yellow. Since a light can't be green and yellow at the same time, these are mutually exclusive events. So if we want to find the probability of one or the other happening, well, we can add the probability of it being green and the probability of it being yellow and get 0.39. So the probability of our light being red is the complement of that. If it's not green or yellow, then it's red. So this looks like the probability of Guy, but it's green or yellow. And then we'll say complement. So we can just subtract that 0.39 from 1 and get 0.61. Again, you might not have had to go through all those sort of probability notation and writing out both of those equations, but it's good to practice the simple ones like you would want to do maybe a more difficult problem. So we now have that the probability of going through the light and it being green is 0.35. The probability of it being yellow is 0.04, probably because the yellow light is very quick. And the probability of it being red is 0.61. So our last rule for today is the multiplication rule. Another rule we'll go into in more depth when we discuss what happens when our events are not independent. But in this case, we're going to talk about independent events. And I'm sorry, my screen is going a little crazy. Okay, so apologies, my pen has stopped working, so I'm going to have to use some typing. But two independent events are two events that have this relationship that when one event happens, it doesn't change the likelihood of the other event happening. So if in our traffic light scenario, if the light is green one day, it's not going to change the probability of it being red the next day. So these events are independent of each other. So our multiplication rule says that if we want to know the probability of two events happening, so the probability of A and B happening, that's what this notation means, we would multiply the probabilities of those two events. So we want to know the probability that our light is red on Monday and Tuesday. So the light being red on Monday, I'm just going to type and because I don't have the symbol. The light being red Monday is not going to change the probability of the light being red on Tuesday. So we take the probability of it being red Monday and multiply it by the probability of it being red on Tuesday, and we get 0.3721. So the probability we hit red lights Monday and Tuesday is 0.3721. If we want to know what happens if we don't encounter a red light until Wednesday, so that is the probability that we have the complement of red. So I'm just going to say red C and the complement of red. So it could be yellow or green. And then on the third day, a red light. Again, these are all independent of each other because one thing happening one day is not going to influence the probability of the light being a different color on a different day. And since we want to know the probability of them all happening, it's an and, which means we multiply. So our probability of green or red was green or yellow was 0.39 and then 0.39 again. So we're not hitting a red light the first 2 days. And then on the third day, we hit the red light. The likelihood of that happening is very small, a probability of 0.0928. That means approximately 9% of the time that will happen, which is not impossible, but less likely than some other combination. And my last question here is we want to know the probability that we have to stop at least once during the week. This one is slightly more complicated, and we have to think a bit logically. So the probability that we have to stop at least once is the opposite of not stopping at all. So let's first find the probability that we don't stop at all. So 5 days of the complement of the light being red. So we know that the yellow light doesn't mean to stop. It means to go faster. No, it doesn't. It means to be cautious. But the complement of being red, remember, is 0.39. So we are going to multiply this 5 times. So we can actually say 0.39 to the 5th power. They're all independent events. The light not being red on Monday is not influencing the probability of the light not being red on Tuesday, Wednesday, Thursday, or Friday. So the probability that we are able to pass through the light every day of the week is 0.0090. So very unlikely, less than 1%. That is the probability of not stopping at all. The opposite of not stopping at all would be stopping once, twice, 3 times, 4 times, or 5 times. So 5 different possibilities, but the total probability we can find by finding the complement of what we just found. So I'm going to say the complement of no stopping. We'll subtract that from 1 and find that it's highly likely we have to stop at a red light at least once per week. So a 99% chance we stop at a red light at least once at that intersection. So I want you to pause here and I want you to try these. If you need help from me, please feel free to ask. If you want to work together, please feel free to ask. Again, this is posted as a PDF on Canvas. If it's tough to see on the screen here in the video, please open it up. Again, I'm happy to help. Please pause here, try these 7 problems, and then press play, and we can talk about them. So hopefully you gave these a try. Check your answers. If you got one or more of them wrong, it's a good idea to go ahead and ask me to check your work, and we can have a conversation of about why the correct answer is the way it is. If you feel confident, though, there are some practice problems I'd like you to do. As always, if you have questions while you're working through these problems, please feel free to ask me. I'm not trying to trick you. I want you to be able to learn this stuff. So take your time on these, and good luck.